Hey, what's up, everybody? It's your boy Algebra coming to you live and direct from the studio, aka your boy's living room. I just wanted to take a couple minutes right now to give you some problems based on what we talked about last time we were in class, solving x squared, but also taking you forward, moving you past that level, getting you to the point where we can solve for an x squared that has a little bit more depth, a little bit more controversy, a little bit more power behind it. So I'm going to start off by having you remember last time. You're following along in the video right now, which you all should be, because that's what the sub has asked you to do today. I want you to go ahead, take out a piece of paper, press pause on your video right now, and get yourself ready. We're going to start off with three example problems. We should be rolling on this video for about 18 minutes today. Uh, and I don't think it's going to be something that's overwhelmingly difficult. If you have issues with it, then we'll be able to talk about those. But I definitely expect you to work your way through this video, having notes, and then start to tackle that homework assignment that you're going to get as soon as you're done. So the expectation one last time is that you watch the video, you take your notes from the video, and then you begin working on your homework assignment, which the sub will give to you upon your completion. First three example problems is strictly based off of yesterday. You don't need to know anything beyond where we talked about. Your homework from last night is due, so you should be turning that in as well. But for right now, we need to start off in the review process. So yesterday, three rules. One, if you have x squared, you're going to get two answers. Second rule, if you have x squared, it must equal a positive number. And third, if you have x squared, you should get rid of it by using a square root. If you use a square root, the square and the square root sign cancel each other out, leaving only an x. And we would break down the other side. You are supposed to know the square root of 81, which is 9. So remember, I said there have to be two answers. The first answer is 9. The second answer is -9. That's where our plus or minus comes from. So two answers are there, and we're good. So we move on to the next one. And the question is 4x squared equals 100. We decided yesterday that remembering the process from first semester is a great jump off point for solving these type of equations. You need to remember SADMAT, where everything that we did in first semester was involving the first four term pieces of that SADMAT process, and now we're just adding in the E. So we're going to save the exponent, we're going to save the square root step until after you've gotten rid of all the addition, all the division, all the addition and multiplication. I think I said addition, I should have said subtraction. My bad. All of that stuff needs to be gone before you get rid of the square root. Therefore, I'm going to start this problem by dividing by 4. I should get x squared equals 25. X squared equals 25. I still have another step to go. That is to square root it. When I square root, my final answer says that x equals 5. But remember, there need to be two answers, plus or minus 5. That is a positive 5. That is also a negative 5. Meaning, if whichever one of these I chose to plug into that original problem, both of them would end up with the same answer of positive 25. So for the third example problem this time, we're looking at 5x squared plus 2 equals 122. I believe that you should be able to handle this, so hopefully you're doing that right now. And I'm just going to chase you through the problem. Get rid of the 2. You left with 5x squared equals 120. Get rid of the 5 on both sides. You have x squared equals 24. Now this presents an interesting problem because I don't know what the square root of 24 is. However, you do know how to break it down. Boom, bam. And breaking it down, I get a 4 and a 6. Break those apart, I get a 2 and a 3, a 2 and a 2. So my final answer is that x equals positive or negative 2 radical 6. So I started off the day with a quick review of yesterday. Now I'm going to take you through a quick review of last week. We spent way too much time factoring things for you to forget that now. I want you to remember last unit. When you see a trinomial, your first instinct is to turn it into either a box problem or a decomposition problem so that you can turn it into parentheses. That is the case. That should be the case. I want it to be the case. Please go ahead and factor each one of these problems. So the answer is magically here. You get x plus 6 times x plus 6 for that first problem. The factoring process is not going to change. I'll go ahead and walk through the next one. Put your first term in the box, last term in the box. Our magic number this time is 100. Breaking it apart, we have a lot of different options. But in this particular problem, the best option is none of the ones I have so far. It's 10 times 10. You break each one of those parentheses apart. Final answer would be 2x plus 5 times 2x plus 5. Now, the reason why I'm spending so much time reminding you about factoring right now, a lot of time being just about 2 minutes, is because I want you to recognize the fact that when you have a factoring problem that ends in the same parentheses, that parentheses being repeated just like if I was multiplying 4 times 4 or x times x, I can rewrite these both as x plus 6 squared. And hopefully that squared is a little bit of information that jogs your memory of what we did yesterday. This is the bridge, the connection. If my parentheses is repeated, it becomes a problem with x on the inside and the squared. So let us get to what is actually new then. What's new is the connection between these two ideas. So if you look at what's happening here, I'm asking you, what if I combine the two ideas? Just so you know, combine is spelled with an E at the end. It is not spelled with a D at the end. It is combine, not combined. So these problems are a combination, not a compounding. And I want to ask you, in the SAT math process, what am I supposed to do when it looks like this? I can't get rid of plus 13 because it's inside of parentheses. I have to do the exponent for the parentheses. So I'll split over. That means I have an answer plus 13. Because remember, the square and the square root cancel each other out. But on the other side, I have 7, which is positive 7, and negative 7 as well. When you solve two problems, x plus 7, x plus 13 equals negative 7. Why? Well, it says plus or minus 7. That means you need to do both. You think back to first semester, we had problems like absolute value, where it said the bars mean you have two answers. Once you get rid of the bars, you can split it apart. Once you get rid of the square, you can split it apart. These things go hand in hand. So if it says x plus 13 equals 7, that means that your x equals negative 7. But if x plus 13 equals negative 7, your x is negative 20. So let's take a look at the second one. It says x minus 6 squared equals 25. And the prevailing wisdom says that if you want to get rid of a square, you square root it. That's going to cancel out the square and the square root sign. X minus 6 equals positive or negative 5, which means I can split it up into x minus 6 equals 5 and x minus 6 equals negative 5. Add 6, x equals 11. Add 6, x equals 1. So just because I have a parenthesis doesn't mean that things have to get overly complicated. It's the same steps. We just need to be conscious of the fact that you're going to have to keep going, because getting rid of the exponent doesn't end the problem. We still have parentheses to deal with. Just a couple more examples and then we'll be done for the day. What if I give you a problem, but that problem doesn't have it in parentheses? I give you a polynomial to start. I say, here's 3 terms, and your first instinct is to box them up. I'm not telling you it's supposed to be any different. I want you to box it up, and hopefully it works out like those problems did earlier, where you have the same this problem square already in the box. And it does follow the formula. Plus 9, happily rewrite it square, and the entire time it still says equals 4. So what we just said is that if this is what I give you, you can still just square root it away, understanding that you're going to get 2 answers. One of them is for the other one is for negative 2. Each one of them is solved when I split it up. Plus 9 x plus 9 equals negative 2. My final answers are negative 7 and negative 11. Looking at the next one, I can already factor this one in. Hopefully you guys are taking your time to do it. go ahead and begin that process while I talk through what's been happening. What we're looking at is what we call a perfect square trinomial. It breaks itself apart so that both parentheses are exactly the same perfectly. And when that happens, you can square root the repeating part away. So for this problem, I get x minus 11 times x minus 11, which can be rewritten as x minus 11 squared. All the while, it still says equals 64. To get rid of that, I just square root it. My result becomes x minus 11 positive or negative 8. Split it apart. Final answers become x equals 19 and x equals 3. So I'm going to scroll down and see two problems that look very similar, and I want you to go ahead and attack the first one and leave the second one until I come back. So hopefully when you look at that process, it doesn't overwhelm you. You just broke it apart. You ended up with two sets of parentheses. That parentheses repeated, so it ended up with plus or minus 1, which is very solvable. So what I'm looking at now is going to ask me to do one last set of things. Oh, wait, I got a negative. Looking at it over on the side, it says x squared plus 8x plus 15 looks very similar. The only difference is the fact that 16 and 1 have been combined this time. Does it change the process? Yeah, just a little bit. And that's where we're going next week before we take our test. Test is going to be either Thursday or Friday. Your choice as long as it's done before spring break. The process we started said it looks like I'm supposed to put it in a box, so I should put it in a box. That part's not changing. Please, after this problem. There's only a few ways to get 15, so you know which one it's going to be this time. X plus 5 and x plus 2, which don't match. But hold on, wait a minute. Let me put some thinking in it. It says my answer last time was negative 5. That's positive time my answer was 3, now it says positive 3. Hmm. Pause, wait. I think that's too much. Let me reiterate this. Last time when I looked at the original problem, it said 16. And on the other side, now it just says 15 with a 0 on the other side. Hmm. Wait a second. Let me really kick this into gear. If I brought zero, so hopefully you're catching my drift that the answer to this problem should be the same as the answer to the last problem because they're really the same problem. And how does that happen? Well, it's because I just break it into two problems. X plus 5 equals 0, meaning I just ignored the second parentheses for a second. Similarly, x plus 3 equals 0 when I just simply ignore the first parentheses. What are your answers for those? Well, your answers for those problems should be the same as your answer for the last problem. X equals negative 5 and x equals negative 3. Oh, that's all your boy has for you today. It's been another broadcast from your boy Algebra, and I'll see you guys next week.